The pH came out to what? 3.35? 8.35? Okay, 8.35. Is that what you guys got? Everybody got the same? 8.35? How did you calculate that pH? The pH was calculated from what?
Using the pKa of the acid and then the log of the base and acid from the H2PO4 and the HPO4.
H2PO4 and HPO4?
Yeah.
Oh, so you got a new ratio?
Yeah.
New ratio, 8.24. All right, so let's go through this really quick and then see what we got. It didn't quite work out the way I was thinking it's going to work out, but let's see what happens. So we end up with 115.0 milliliters, let's say. It's about 115 milliliters. And so what was the new sodium hydroxide concentration?
0.7826.
0.7826. So what everybody got?
Yeah.
HPO4 2 minus?
0.4495.
0.4495. The H2PO4 minus?
0.8695.
0.8695. And so here we see a more significant pH change because if you look at the sodium hydroxide, it's 0.7826, and the H2PO4 minus is 0.8695, which means we're getting close to the capacity. Right, the capacity to neutralize the added base in this case. This is this is different capacity. For example, if we neutralize added acids, it has a lower capacity, about half as much capacity as it has to neutralize added base here. And then we end up with getting a new ratio, and we see a more significant pH change. Right? Maybe I gave you way too much time for that particular problem, but let's try this problem again. But we're going to try this with this. We're going to go with, how many milliliters should we go with? Let's go with 20.
19.
Well, actually, let's go with 30. Keep it simple. 30.0 milliliters of sodium hydroxide. Will that do it? Let's try that. We did what, 15?
Yeah.
Let's try 30. And then repeat the calculation. Oops.
So are we forgetting about the last example? Are we going to forget about the last example?
Oh, did everybody get it? Or not everybody got it? Not everybody? Oh, I thought everybody got it. Oh, okay. Then let's finish this. No, okay, so not everybody got it. Then what do you do next? This is step A. What's the next step? Strongest acid plus the strongest base. So the strongest acid present is H2PO4 minus. The strongest base? This forms what? Water. HPO4 2 minus and sodium minus. You just plug it in, the values. The H2PO4 minus is 0.8695 molar. The sodium hydroxide is 0.7826 molar. Water, we ignore. HPO4 2 minus is 0.4495 molar. What's K for this? Very, very large. Right. And so what's the limiting reagent here? Sodium hydroxide. So this goes down to 0, minus 0.7826 molar. And so we're going to have what here?
0.0869.
0.0869. So now X is more significant, the change over here. And then we're going to have plus 0.7826 molar, and that gives me at equilibrium how much?
1.23.
1.23.
21.
21?
Yeah.
What do you see left over? In step 1. Step 2, you see a HH buffer. And so for this HH buffer, it's pH is equal to the pKa of the acid. What's the acid? H2PO4 minus. Plus the log. This time I'm not skipping the step. Plus the log of the base. The base is HPO4 2 minus, and the acid is H2PO4 minus. Yeah, sorry, I thought, this being exactly the same type of problem before. It would be although it's sodium hydroxide this time. The pKa was what again? Plus the log of the 1.232 over 0.0869. We got a pH of
8.35.
8.3.
1.
Thanks. All right. So it's the same exact thing, except rather than HCl, we're using sodium hydroxide. And the other thing is, now we're starting to get close to the capacity of this buffer, because now we're seeing bigger swings in pH. So the thing we have to do is either increase the capacity or use more buffer. Rather than 100 milliliters, if we use 1,000 milliliters, it'll have a smaller impact. Now we're going to repeat this with 30 milliliters of 6 molar. So do you want to do sodium hydroxide, or do you want to do acid again?
Sodium hydroxide.
Sodium hydroxide again? Okay, let's do 30 milliliters of sodium hydroxide. Do you think this might exceed the capacity of the buffer?
Yeah.
Maybe. Let's see. All right, so go ahead and do step A and continue with this. So it's just a repetition of the same problem, same type of problem again.